Alright, in this video we're going to look at recrystallization. This is a method that is used to purify solids by removing both soluble and insoluble impurities. It requires the solvent in which the substance is soluble when the solvent is hot, and the substance is going to be insoluble when this solvent is cold. So the choice of solvent is really important in this technique. Okay, so first we're gonna dissolve the impure solid in the minimum volume of the hot solvent. Alright, we're gonna warm the solvent that we chose, and we're gonna make sure that it's hot, and we're gonna dissolve the impure solid in it. It is crucial that we use the minimum volume though, so that the solution is saturated with respect to the main solute, but not with respect to the impurities, which are present in much smaller amounts. Okay, so that's the first thing that we need to make sure that we do. Second of all, we need to filter the hot mixture that we obtained, and we need to but it has to be through a warmed, preheated filter funnel to remove the insoluble impurities. It is also important that we use a warmed filter funnel so that to prevent the solute from crystallizing and blocking the funnel. So after doing so, we're going to allow the solution to cool and for the crystals to appear. We're going to then filter the cold mixture containing the pure solid under reduced pressure using what is called a Buchner funnel. So that's just a type of funnel that we're going to use, and this is really a fast process to filter the mixture. So it's really convenient to do that. Okay, so then we're going to discard the liquid filtrate from our filtration, and we're going to which contains the soluble impurities, and we're going to collect the solid crystals that are on the filter paper and wash them with a little cold solvent to remove any soluble impurities remaining on the surface of the crystals. So we did remove the soluble impurities from the liquid filtrate, but there might be some remaining on the surface of the crystals. So to ensure that it's really pure, we just use a little cold solvent and we remove any soluble impurities remaining on the surface. But you should also note that we use a little cold solvent, and we don't use a lot though, we use a small amount, so that the crystals aren't washed away. Okay, because if we've used too much, the crystals might be washed away and we've basically ruined the whole process. So after doing so, we're going to transfer the pure crystals to a desiccator to dry. So this is just we're going to dry it using a desiccator, and we must note that we do not use an oven to dry it, because if you use an oven, then it might, at really high temperature, you might decompose the crystals. So in actual fact, you haven't dried it, but you decompose it into a different substance. So we use a desiccator to dry it, so the crystals are still the same substance that we want. So now you've obtained your pure crystals that is dry and completely of any does not contain any impurities. We just need to do one last thing, and is test the purity of the crystals, and that is done by determining the melting point. So this is just one thing you're gonna do after you've basically obtained your crystal, but we don't know how pure it is. So we just look at the melting point of that crystal just by putting it in like a capillary tube and melting it in a test tube and just measuring the temperature, measuring the temperature once it melts. Once you do so, you just compare it with a databook value and look how far off the melting point is from the actual value in the databook of the substance. Once you do so, you'll find out how pure it is. If it's really off the value, then it's not pure, and we need to do the process again or do a different technique. But that is basically the whole point of recrystallization and how we do it. Thank you.